Okay, let's do this College Board Unit 3 material. So this is what we did at the very beginning of the year. We did Unit 1, it's experimental design, okay? And so in this first problem we did was 2019 question number 4, I believe. And so this was about an experiment that was performed on fruit fly, or the flies, but the key was the insects, on the insects. But the key is that they had taken these insects and they put an equal number into these 20 individual containers. So that right there caused a lot of confusion to people the year that this problem was graded. And that came specifically, the treatments we were fine with. There were 4 treatments, and they were the 0, 125, 2.5, and 3.75 milliliters of fungus. To get credit that year, you did not have to say that what the units were. You didn't have to say the specific concentrations. You just had to say there were 4 different concentrations of fungus spray. Okay. But then here's where the problem rose. Separated the E's from the P's. The essentially correct from the partially correct was the experimental units. Okay. Because the experimental units were actually not the insects. And the reason it wasn't the insects is because a treatment was applied to the container of insects. So the correct experimental units, you could say the flies in each of the containers. So think about it this way: 20 different containers got the treatment. And then within those, there were a bunch of flies, so that we had repetition also. So we had double repetition. But the key was that the treatments were randomly assigned to a container. So it says the group of insects in each container will be sprayed with one of the 4 mixtures. And definition of experimental unit is that the objects subjected to a specific experimental condition. So what that means is the group of insects in each container are who received the treatment. So that in each of the containers had to be mentioned. You could say 20 containers. You could say the containers, the 20 groups of insects, because that was groups of insects that implied the 20 containers that contained the insects, the group of insects in each container. So what you couldn't say is just groups of insects, because that was unclear if the groups were the treatment or the 20 different containers, or if it was the groups of insects, meaning the group that received this treatment and the group that received that treatment and the group that received that treatment. So you had to mention in the containers to get credit for experimental units. Okay, next. Response variable. So this was tricky in that it was a numerical value. So think about, remember, response. What are we getting from each one of those containers? So if you had done the experimental units correctly and you said 20 containers, then what you would get from each of those containers is the number of insects that survived, okay, that are alive. Okay, now they gave you credit for this component number 3 response variable if you missed experimental units and you just put the insects, if you just put the insects as experimental units, which I'm not going to lie, I might have done that before I understood that this is a big deal, that you have to be that specific on what groups are receiving that treatment. But anyway, so if you had just put the insects as the experimental unit, you could still receive credit on the response variable if you said something like whether or not the insects were alive, okay, or the proportion of insects who who lived, that kind of thing. So if you said the insects, then you had to have this whether or not the insects lived in response variable. But if you did experimental units correctly and said the containers, then it was measuring the number of insects that survived. Okay, that was a tricky one. That was where most of the separation between this in this problem was done. Okay, so if they were all three correct, you get an E, only two correct, you get a P. So now let's take a look at this next section. This next section it asked you a few things. It says, does this have a control group? And to explain it. So yes, it has a control group. The control group is the groups or the containers that received 0 milliliter that had no fungus in the spray. Because I think they all got sprayed. Didn't everything get sprayed? Yeah, they all get sprayed. It's just that some of them had like 0 milliliters of active ingredients. Okay, so they all got sprayed. It's just that the group that had 0 milliliters of the active ingredients of the fungus, that was the ones that were the control group. So here, you didn't explicitly have to say yes if your explanation was like, the control group is the treatment, the containers that got 0 milliliters of fungus in the spray. Here's the ways that people got partial credit. So we had a lot of partial on the first section and a lot of partial on this second section. But here's the way you would have gotten partial. If you say there is not a control group because every container is sprayed with a mixture, and they are, it's just that one of them doesn't have the active ingredient. Okay, now the other way to get partial credit, if you said something, and this is probably the one that most people got docked for. They recognized, yeah, there is a control group, but they then botched it up because everybody got sprayed. But they might have said something like the containers that had no treatment, or they said the containers with 0 milliliters because they don't receive a treatment. That was the thing that got people and marked them down from an part E to a P in this section. Yes, they all are getting a treatment. The treatment is a spray. The control group is the one that had 0 milliliters of that active ingredient of fungus that they were testing. Okay. All right. So now let's move on to the last one. So this one was how would you do this randomization procedure? So there was, man, this problem actually ended up being a very lengthy grade because in the whole nation, there's tons of ways that people described their randomization process. Now, I've simplified it and kind of just have told y'all one way to do it is that big hat method or the big bag. But anyway, describe how the treatments can be randomly assigned to the experimental units so that each treatment has the same number of traits. Okay, so if you chose the experimental units as the flies, then you could have said put all the flies in a big bag, shake well, and then pull out however many flies, because I don't remember if it told you a total, for this mixture, or a fourth of the flies for this mixture, and then the next fourth gets this and the next fourth gets this. That's fine. Here's some things that you need to make sure that you incorporated in that description, that you okay, so they actually put separately somehow some kind of labeling for the units or the treatments. But I think if you put all the flies in if you chose insects as your experimental units, then your credit would have looked like this. Put all the flies in a big bag, shake well. Pull out the first fourth of the flies. And you have to, this past year, you had to make sure you stated the flies are not replaced. So when you pull out those the fourth of flies and you assign them to the 0 milliliters of active ingredient, okay, that is you then labeling the treatments that you're sending them to. And then without replacement, you take out the next fourth of the flies or whatever, and you send them to the whatever that treatment was. Okay, that would have gotten you credit because you showed this random assignment. you showed an equal number of units assigned to each treatment. So we had a fourth of the flies going to each one of the things. But remember, this past year, they were specific in saying that you had to say that when you pulled out of the bag, they were not replaced. And so that was a big deal. All right, next, the other thing that you had to make sure that this had shaken well, that those flies are in there, they are shaken up, so they are randomized, and then you are taking them out. Now, if you had done the correct experimental unit of the containers, the 20 containers, then you could say label the containers 1 to 20, or you could even say label 20 batches of mixtures of spray and so you have 5 of the 0 milliliters, 5 of the 5 milliliters, 5 of the whatever. Anyway, you had papers with either the treatments on them, equal number of treatments, or the 20 different containers. And then shake well, and then you pull out a slip of paper, and if you said label each container, then you would say the first 5 numbers that I pull out without replacement. So when you pull out a number 3, it stays out, and container 3 gets the 0 milliliters of treatment. So pull out 5 containers without replacing them. Key, big deal. That's now going to be like the E versus P criteria that I see a lot. Okay, without replacement. Pull them out and assign 5 of the containers to the 0 milliliters, and then pull out the next 5 containers without replacement and assign them to the 5 milliliters or whatever. Okay, and continue. So if you had some kind of labeling, like you were specifically saying which treatments, so that we had 20 of the containers or 20 of the treatments labeled, or you pulled out that kind of thing, then you got the credit for that. You shook well so that there was randomization. And you disregarded the repeated numbers. So the third thing is that they are pulled from the bag and they are not replaced. Okay, so then that's, if you get all those, you get 3. If you only got 2 of those, you get 2. So I could see a lot of people say maybe getting PPP on this one. I'm not so sure I would not have. They were so specific on a lot of the things. If you would have gotten a PPP, you would have gotten a 2. And that was very solid on this. In fact, I could go look up what the average was for this, and I might before I have it in Free Response Flex Friday tomorrow. But this was a low scoring problem because of the specifics that they looked for. But anyway, so if you had all 3 E's, then you get a 4. EEP or EPE, whatever. 2 E's and a P is a 3. Here's the different ways you could get a 2. 2 E's, EPP, EPI, that's like kind of like 1.5 and 1.5. And then a minimal response, I think this was a EII. So there's that, or a PPI. All right, so now let's move on to the next section. So we did not do this problem of 2016. We continued on, and I had you do this of 2014, problem number 4. So I think the thing that gets me on this problem is that they had 3 sections in the grading when only 2 questions were asked. I even went back to go look back at this problem to see. See, they just have part A and part B. And I was like, okay. So I was wondering why they had another section that they graded to get that component. And so anyway, we'll go through that. Okay, so this was the reunion in 1988, and people were saying what their salaries were. So in the first question, what's the statistical advantage of using the median to report the income instead of the mean? A statistical advantage. So why is the median better than the mean? Well, if you take people's salaries, okay, so think about this. Besides the fact that they might misstate their salaries, but even if they did it, say, anonymously, okay, let's say they did it anonymously so that we didn't have the bias associated with that. We're just talking about straight up statistical mean versus median. Well, I expect that we're going to have some kind of skew, or we're probably going to have some outliers. So we could have somebody who's done some app and they're now mega millionaire or whatever. So we've got a few outliers that are way high. Now, therefore, you had to say something about how the skew or the upper outliers affects the mean. And then we had to go with so acceptable responses. The mean is affected by the skew, or the median is not affected by the skew. You could say the mean is greater than the median when there are upper outliers. So something about saying how the mean and the median are not similar. Okay. Now look at this not acceptable. The median should be used for skew, and don't use the mean for outliers or skew. So these two were not specific enough. The idea was you stating they are not the same for mean and the median because skew or outliers affect the mean. Okay, now then you had to connect to the fact that that income has potential outliers of some sort. Whether you said lower outliers or upper outliers, it did not actually matter. It was just saying that salaries are probably prone to having outliers or skew. And so, because salaries have that, then to get a more typical value, you should have median. It's more centrally located, whereas mean is then pulled in that direction of the skew. All right, if you got both of those, you got an E. If you only got one, you got a P. Next, then they said they suspected maybe we need to do a better job at getting a more representative sample. So they offered two different methods: sending out an email asking people to complete the online form versus selecting a simple random sample. So there's the randomness, and then contact the random selection of people and ensure that all the responses are obtained so we don't have non-response bias. Okay. And so on. So even though method 2 is actually a smaller amount of recipients, we know from inference that 100 is large enough, so we're going to be good. But here's the issue here. There's no randomness involved in method 1 because having certain members respond voluntarily, of course, is going to lend itself to some type of bias, because only those who are proud of their salaries or whatever will probably take the time to respond. Okay, so here's how you got credit for this one. You identified method 2 as the best, and it's because, okay, there we go. You identified somehow that method 2 was the best. But then you had to say what was not desirable about method 1. And I think it'd be good to say method 1 did not have randomness. That would be a good one, because it just had people volunteering to send in their response. So only those people who are maybe proud of their salaries will take the time to do so. So it's not representative of all the people. Okay, 2, then you have to say the way 2 is good. 2 is desirable because it is random, it has random selection. So that's more likely to be representative of all the alumni as a whole. Here were ways that you could have gotten partial credit. You chose method 2, but you did not say the characteristics of both bad for 1 and good for 2. You just maybe said one of those things. Okay, the way to get partial credit is that you didn't specifically say which one was better, but you said 1 was bad and 2 was good, but you didn't say which one to actually choose. So that would have given you partial credit. All right. If you got all of those 3 things, though, you did all 3. This should be it. All 3 of those things you would get. That would be correct. Okay. Now, this is the part that blew my mind. I was like, okay, where did this come from? So they added this layer of thing that they were checking for. And so this came from any of your explanations. So we as graders just had to go and search for this information throughout any of your explanations. So if you said somewhere that the income of the people who respond is probably going to be different than the people who did not respond, that checked that box. You had to somehow say anywhere in there, those who want to respond probably had higher salaries. That checked that box. Okay, so something different between the responders and the non-responders. Okay, that creates undercoverage is what they're getting at there. All right. You also had to say that the biased sampling method produced misleading estimates. So somewhere, see, here's the thing. And I think this is probably where people got P's instead of E's on this section number 3. Here's how it happened. You had to somehow say that method 1 would be more likely to be a higher estimate than the true estimate of the population, because people who are proud are going to take the time to respond. And so those people who are proud are people who had higher salaries. They're going to respond. So we're naturally going to get a higher average if we go with method 1 than the representative average that we would get with method 2. Okay, so if you included those two things, good for you. If not, so if you didn't get that and state that method 1 made a higher average than method 2, you just got a P in this section. So you might have gotten EEP, but that's still a 3, and that's great. So let me talk to you through that specific. Oh, I don't have that here. Okay, so we can see then that, and I can go ahead and put that in here, that if you got a 4 if you had EEE. If you had 2 sections where E and 1 was a P, then that gave you a 3. Okay, so here's the way you could get a 2. You had 2 sections were an E with an I. You could have 1 section was essentially correct. And so here you could have EPP or EPI. And then finally, you could also have PPP. Okay, so there's lots of ways that you could have gotten a 2, 4 different ways you could have gotten a 2. And then a minimal response. So you could have gotten EII or the PPI. Okay, those are typical. That is typically the way that scoring is done when they have 3 sections. All right, so there's your end of Unit 3 on experimental design, the type of questions that you might see. So I hope you did well, and hopefully we'll see you back for Unit 4.